So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about a very unique topic, and that is customizing CAD for industrial component design. And the idea behind today's webinar is to get you thinking about creating custom features in Onshape, customizing Onshape in a way that fits your application. And I think a unique way to show you that is to walk through how another industry might do something like this. So go through a couple of industry-specific features that have been created that are publicly out there and show you examples of how those can apply in their particular world and how they can save them time, energy, effort, make them more consistent, and so on. So the topic today, again, customizing CAD for industrial component design. Now, as I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in your GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and answer the questions as we go through today's webinar. It's going to be a short webinar. We're really going to focus on just a few different examples where custom features and FeatureScript in general can be used to create industry-specific applications that can save the engineer a lot of time. And that's really what we're going to focus on here is, a lot of the things that you can do with FeatureScript are pretty specific. And what I mean by that is you can create a feature that does what you do quite often, what you find tedious, and eliminate a lot of the work, but that's more specific to your industry and the type of work that you do. And so this isn't something that's necessarily going to apply to everyone. If you're satisfied with the standard list of tools that are in the toolbar, great. You'll never have a need for a custom feature or feature script, but there's certainly a lot of potential to save time and, again, create better consistent models, increase your consistency, of course, and eliminate a lot of the potential for human error. And I think that's one thing that's worth mentioning with custom features is just the consistency means you never have to worry about did the operator make a mistake, right? All right, so let's dig into it. Now, the agenda is pretty simple today. We're going to start with a simple introduction into custom features. So if you've never heard of custom features or FeatureScript, we're going to give you a simple intro into what those things are and then how to apply them. And I think the big thing that I want to stress here today is, we want to discuss its impact on the everyday engineer and how that can make them more agile, make their time to market quicker, right? That's really what this is all about is, how can we create an accurate, consistent design faster and with less effort, right? And so that's what we're going to focus on is just some ways that this will have an impact on your design team's agility. Of course, I want to go through, a few examples of custom features, show you a few examples of where you'd use them, and also a few neat features if you're interested in how to use them, right? There's a lot of publicly available features that anyone can use. You don't have to know how to write any code, and you can start using them today. And I'll show you examples of where you can find those and how you can add them to your toolbar, and we'll get into that in just a bit. So even if you have no interest in creating your own feature, definitely stick around. I will walk you through how to, add a new feature and potentially use it. Now, the last thing I want to do here is really show you how to create a custom feature. I think the end goal here today is to get you thinking about creating your own feature and the areas where it might apply. Think of those areas where you just find yourself doing a lot of tedious modeling, stuff that you do quite often. You do, to the point where it's just taking up time. It's no specific special thing that you have to do yourself. It's something that can easily be repeatably done. So think of those kinds of examples where you could really save yourself a lot of time with a custom feature. So that's a short rundown of the agenda. Let's get into custom features. Now, the key thing that I want to stress is this isn't necessarily for everyone. There are a lot of users out there that will have no problem using the standard sets of tools, right? The standard sets of tools is very similar to what you're familiar with in other CAD systems. This is really for those that are trying to build something custom for themselves, that really want to go that extra step and build a custom feature that applies to whatever they do. Or maybe they want to see what other custom features have been publicly available that might apply to what they're doing. But let's talk about features first. First thing to keep in mind is every CAD system has a standard set of features, and many of them are very much the same, right? Extrude, revolve, sweep, loft, those are commands that exist in Onshape, they exist in SolidWorks, they exist in Creo. So every CAD system has their standard set of features, and it's not just those four, of course. You have fillet, shell, patterns, holes, those kinds of things are pretty standard in all CAD systems. What's really unique about Onshape is that we are publicly releasing that source code for those features. Now, you may ask, well, why is that important? It is particularly important when we start talking about building on top of custom features. In other CAD systems, you have functions like the API, but you don't really have core access to the source code that drives the part modeling environment, right? So in Onshape, you can literally look at the extrude source code, the revolve source code. So the reason that's really critical is because a lot of what you may want to build is building on top of those standard building blocks, right? I want to automate a process. That process is, I want to draw out this sketch and I want to revolve this profile. Well, I can easily cut and paste sections of Onshape source code into my own variation of that command, right? A lot of users have asked, is it possible to change how the features work? I think that's one of the commonly asked questions is, what if I wanted to add a checkbox to the extrude command that did this? What if I wanted a certain option in the loft command that allowed me to do something? Well, chances are you can build that yourself, and it wouldn't be that difficult. You can take the source code from Onshape, create your own custom feature with it, add your code for your option, and you're off and running, right? You're taking that foundation of Onshape's features and just building on top of it. So there's a few different examples I would stress, but the big thing is, if you've ever had a scenario where you wish that you had an interface where I could enter in a few values and boom, it just popped out this shape. Chances are you can create that with FeatureScript. If you've ever wished that a certain option existed in a certain command, well, chances are you can build that if you're ambitious, right? If you take the time to do so. Now, it's not that difficult. I'm going to get into an example of what I mean by that in just a second. The thing that I would stress, though, is with Onshape, it's possible. In other CAD systems, a lot of people are familiar with the process of submitting an enhancement request or submitting an improvement request or something to that effect, where you're essentially sending all your details to the CAD company and they review it. And oftentimes the result there is either you get no response or the response takes several years and it's just not practical for what you're doing. So it kind of puts the power back in your hands. Having the ability to build your own feature means that you can essentially work on your own and not be dependent on the CAD company to do a certain thing for you. Now, if you're familiar with macros or APIs, this is a bit different in that, again, that core underlying functionality, the extrude, the revolve, the sweep, the loft command is available to you publicly. So that's kind of a simple intro into custom features. We're allowing you to essentially take our foundation of the part modeling environment and build on top of it using whatever kind of feature that you want. Now, how does this apply to agile product design? The key thing here is you can create geometry quicker and with more consistency. And I think that's the big thing that I want to stress here is you can take something that is, potentially 15 minutes, 20 minutes, 30 minutes, even more, and turn it into a few mouse clicks, right? Especially more complex operations where you find yourself tediously modeling this, silly shape, and then you're having to do this all the time. And you realize that there's, got to be some faster way to create this, right? And that's where FeatureScript comes into play. And it's really just about creating quicker designs. More iteration means I need to be able to get things done quicker, and more consistency. I don't have to worry about is there an operator error where they entered a wrong value, or is a typo, or all those kinds of things, because I've eliminated that element of it. So changes can be made quickly. Another thing I always like to stress is if you've created a custom feature, you will see it on mobile. And you can create a custom feature on mobile. You can edit features on mobile, even custom features that you've created. Now, the focus of today's webinar is really going to be on industrial component design. I'm going to focus on things like gears and splines and belts and those kinds of operations, but realize that this applies to many different industries. And I think that's the big thing I want to stress here today is the furniture industry has a lot of practical applications for FeatureScript. And you have industrial components like we're talking about here. There's all kinds of examples where the industry it applies specific to the industry, but it can make a big difference in that industry. And I have a few quotes that I always like to mention when we talk about, what can FeatureScript do for me? What's the point of creating a custom feature? And one quote is, FeatureScript is saving me so many hours that it changes my complete workflow. The Dowel Minifix feature just became my most used tool in Onshape. I'm thrilled that a small Finnish furniture company can now use its own own feature in world-class CAD. So again, this is a good example where we're saying so many hours. I'm saving a lot of hours just by creating this dowel minifix feature. Dowels and minifixes are a common thing in furniture design, right? So rather than manually modeling them every single time, he's created a custom feature. That's just one example. Another example, I think FeatureScript will help us create unique tools to differentiate ourselves from our competitors in the 3D printing space. And that's one area that's worth mentioning. If you're designing a certain product and you have competition that designs a very similar product, you have a distinct competitive advantage if you can create things in a faster fashion, period. And a lot of that has to do with the design process. If you can, create a smoother workflow for your design process that eliminates a lot of that tedious headache, you can get products out faster and iterate faster. And that's really what agile product design is all about. So these are just a couple of things, but I think if you had to take away anything from this webinar, I think the big thing is you can create that, tedious geometry, that complex geometry very quickly and with more consistency than you otherwise would, right, if you were to do it by hand. All right, so the next natural question, what if I don't write code? And the answer is that's fine. You can still use a lot of custom features out there. And I say a lot, I want to say there's, a few dozen publicly available that Onshape itself has posted. There's many that are publicly available from the Onshape community. I'm going to show you an example of where you can find them and how you can add them to your toolbar in just a bit. But the big thing I want to stress is don't worry if you don't know how to write code. If you just want to use one of the already existing features that exists, you don't have to. You don't have to write code. You can just add it to your toolbar with a few clicks. So it's very easy. Now, I would also say that FeatureScript is very easy to use. So I'm going to give you an example later of creating a custom feature just to stress how easy it is, because it's a very simple interface, very easy to write custom feature. So if you don't have a lot of experience with writing code, but maybe you understand kind of the fundamentals, FeatureScript is a good language to start with, especially if you have a CAD background and just a little bit of programming. It's definitely a very easy to use language. All right, so without further ado, let's jump into it. Now, what I'd like to do is walk you through a simple example of where a custom feature might apply. And as I mentioned before, industrial component design is a very big industry that has a lot of very standard features. And what I mean by standard is they conform to standards. Maybe they conform to a certain spec according to an ASME standard, for instance, or an SAE standard. There's these standards, and basically the shape is the same, but according to different sizes, it conforms to a certain standard. So it's one of those areas where it really lends itself to FeatureScript programming and the FeatureScript custom features. So let me give you an example. Here I've designed a hydraulic steering pump. So this is the assembly for my hydraulic steering pump, but I have a few things that I have left to do, a few things that I need to design in this hydraulic steering pump. Namely, if we hide a few of these parts here, you can see I have no gears, even though this is a gear-driven pump. I do not have the gears modeled yet. I also don't have the spline on the end of my shaft. Right? And these are common operations in industrial component design, and these are both examples of tedious operations. Constructing a gear, constructing a spline profile on the end of a shaft takes a lot of time. It also takes looking up a lot of standards and figuring out all the details. So this is a prime example, prime candidate for FeatureScript. So let's jump into the Part Studio for this assembly. Now, this is the same shaft that you saw in the assembly, and what I want to do is I want to add my gear, and I want to add the spline to the end of my shaft. Now, that spline is just a cut created in the end of the shaft so that you can mount this to something else. And again, both of these are examples of rather complex shapes. You would have to spend a lot of time looking up standards and then figuring out, what that is in my model. What plane do I put it on? What are all those details, and manually sketching it. So a good example of this is a gear. Spur gear, if you've ever sketched one, is a very complex shape. Now, there is a custom feature publicly available to everyone out there called spur gear that will allow you to create a spur gear just by entering in values for that spur gear, right? So the key thing that I want to stress is many of the commands, all the commands that I'm going to show you here today, are publicly available. So even if you don't write code, everything I'm showing you here today you can use. You don't have to write code to use it. Now, the way that you add a custom feature to your toolbar is on the far right of the toolbar in your Part Studio, right? Very important to note, in your Part Studio, far right of the toolbar, you're going to see an icon that says Add Custom Features, little plus icon. Right? If you left click that, then it will load the Add Custom Features dialog where you can select what features you want to add. Now, there's two really important filters to know if you want to use a publicly available feature, and that is FeatureScript samples and Community Spotlight. FeatureScript samples are samples of FeatureScript created by Onshape, and the Community Spotlight is just spotlighted features created by the Onshape community. Both of these have a lot of really great examples of FeatureScript and a lot of very useful features, right? Even if you have, a practical application for your gears, you have a command for that, right? You can see here's that spur gear feature. The straight spline feature, the feature we're going to talk about in a moment, you'll find it here as well. Belt, we're going to talk about this in just a bit. But the main thing I want to stress is, you can add any one of these commands to your toolbar just by left-clicking and selecting that feature here. And what will happen is you'll see a new icon added to the far right of your toolbar. Essentially, you just added that icon to your toolbar, and you'll see it throughout all parts in Onshape. So that's really all it takes. If you want to try a custom feature, it's very easy to remove them as well, so don't be afraid to try them. Just right-click the actual icon, and you can remove it from your toolbar. But there's a lot of really neat features. One commonly asked question I get is, do we have weldments? Do you have the ability to sweep profiles along a path very easily, standard shapes? And the answer is yes. You'll see a beams feature, custom feature here as well, wiring feature. We're going to discuss spur gear in just a moment. But again, lots of very cool features, and not just the FeatureScript samples, but also features in the Community Spotlight. Aerofoil scripts, parametric curves, all kinds of very cool stuff that's worth checking out. And the neat thing is these don't cost you anything. Very easy to add to your toolbar, remove from your toolbar if you don't care for them, but have a lot of power, a lot of potential. So you'll see on the far right of my toolbar, I've got a lot of custom features added to my toolbar. I've got belt, embossed foot, fill pattern, all kinds of different things. I'm going to start with spur gear, and I want a 10-tooth gear. Right, pitch circle diameter 1.75. I want a center bore with a bore diameter of 0.937. And I want to select the origin position and left click the point where I want to place that. So you're going to see I'm essentially just inputting values for my gear. I'm not worrying about, am I sketching the correct curve for the gear tooth profile or any of those kinds of, I just input number of teeth, pitch circle diameter, center bore diameter, place it. I can even do things like, add a keyway if I wanted, right? We can define our extrude depth for the gear, right? I hit the green check OK, and now I have a custom gear defined by my input parameters, right? And so that's, again, a very complex shape to have to sketch manually. You spend a lot of time. We're talking potentially 15, 20, 30 minutes sketching a single profile just to create that gear. And it's something that's reduced down to just a few clicks with something like FeatureScript. Now, let me give you another example of this. One common operation in industrial component design is spline shafts and mating pumps to motors and things like that via spline shafts. And spline shafts is another example of something that conforms to a standard, right? There are certain standard size spline shafts. So this is another example where FeatureScript can have potentially a lot of power to save you some time. There's another custom feature that's worth mentioning. You'll see it's called SAE Straight-Sided Spline Feature. And as the name implies, it creates a straight-sided spline on a shaft. And it's pretty straightforward. You define what kind of standard you want. You have 4, 6, 10, and 16 spline. And you define the end face of your shaft. Right? So I click the end face of a shaft, and it applies the spline definition to it. Right? So again, end face of the shaft, and it creates that spline. I can choose 6 spline, 10 spline, and you can see it'll update as I go through and do that. So it's one of those commands that is just really saving me a lot of looking up a lot of values, constructing a few complex sketches and a few features, creating a pattern, and so on. Right? It's doing all of that in a single step. Now, the really unique thing about this command is it will conform to a standard. What I mean by that is it will not allow you to create a spline feature that doesn't match the standard. And so there are certain defined sizes within this standard, right? And in this example, this is, I believe, a 1-inch shaft, and there's no formal 16 spline definition for that. So if I choose 16 spline definition, the feature fails. And that's because it knows that there's no formal definition, there's no defined standard size 1-inch 16 spline, right? The max number of splines that you have is 10. So the main thing I want to point out here is it will not allow you to create a spline feature that doesn't conform to some kind of a standard. It checks the diameter of the shaft and applies the appropriate spline definition based on that. So it's an example where I eliminate a lot of the human error, a lot of the inconsistency that can come from just tedious modeling operations, sketch mistakes, typos even, where they can have a big impact on how things go together, especially pumps lining up to shafts and so on. But pretty straightforward features to use, right? I have straight-sided spline. I can define my spline length, and define it, make it a little bit longer, the green check, and now I have my spline feature. Question: is the spline length actually 1 inch? Well, the way this is defined, and if you'd like, you could take a look at the source code. It is publicly available, but it's from the end face to where it starts the revolve cut that creates this, upper revolve shape here. So it's from this face to that point, and then you have whatever revolve cut is left after that. All right, so that's an example of a straight spline. And the thing that I'd like to stress with that is it's an example of a feature that conforms to a standard, right? You can only create standard shapes, right? There's no potential for error because the feature simply fails if you don't select the correct thing, right? All right, so let me give you another example of this. Let's jump into the pump housing here. And so as I mentioned before, this is a gear-driven hydraulic pump. So in this example, what I'd want is essentially a hydraulic port on the backside of this gear-driven hydraulic pump. So those hydraulic ports, if you're familiar with them, are very specific shapes. They're holes, but they're complex holes, right? They're holes with many different diameters, many different steps, so to speak, in the hole. And again, it's another example of something that conforms to a feature or to a standard, right? So, a hydraulic standard, one example of it is an SAE standard, where there's a 1-inch standard, a 3/4-inch standard. There's, X different sizes for all these standard hydraulic ports. So this is another example where FeatureScript is really valuable. Another publicly available feature is the port feature. And like the name implies, you can define what size hydraulic port that you want. Now, right now, this is just the SAE standard. So it's conforming to one very specific standard. But it's an example. It's mainly just an example of how it's very easy to take a complex shape and turn it into a couple of clicks. If you're familiar with hydraulic ports, you'll know you can sketch out a revolve profile, but it's going to take a while. Here, I can just say, okay, I want a 1 1/16 inch port, and I want it to be 2.5 inches deep, and I want to put it right there, right? And you can see it's going to go through and create that port profile very quickly. Right there's, you can see 1, 2, 3, 4, 5, 6 different diameters, different shapes in this single revolve profile. Something that if you had to sketch by hand, it would take quite a while to do. And another example where if you work with hydraulics often, you probably have to sketch these quite often, right? And it's a tedious task. So again, another example, ensuring consistent design, conforming to standards, eliminating tedious effort, all great examples where you can make your design and your team just a little bit more agile. All right, so I see a few questions that I missed. What if a feature gets outdated after I've used it? Will my model fail? No. So it's important to keep in mind the linked feature that you import into your toolbar and you use in your document is tied to a version that will never change. That means the person, if the feature gets deleted, the person that created that feature that you're using, even if that document gets deleted, your feature rebuilds just fine, right? Now, you won't be able to add new instances of that. You won't be able to add new features, but it will never impact past features. And that's because it's linked to that static version in the document. So don't worry about, if I link to a feature and then that feature all of a sudden disappears, do I lose everywhere else where I used it? The answer is no. Question. I know it's not a topic, but it exists a feature script for angular teeth on spur gears. Forgive me if I'm not 100%. If by angular teeth referring to like a helical, forgive me if I'm not following. I would say as of today, no. Do you also have ISO DIN standards? Not in this command, but I would say, and I want to stress this, that all of these features that I've shown you so far are open source and publicly available. And I'll show you an example where you can find the source code for them in just a second. Good question. Can we write FeatureScript scripts that apply to a drawing or an assembly, or do scripts just apply to Part Studios? As of today, they only apply to Part Studios. So very good question. FeatureScript is really about creating CAD features. It doesn't do anything else with regards to assemblies or automate drawings. We do have a formal API, Onshape API, which is a separate thing, which can handle a lot of that. But it's important to keep in mind, as of today, FeatureScript is strictly about CAD features, part modeling features more specifically. Question, how do I create a library of my beam profiles that is accessible from the standard beams tool? I'm assuming, forgive me, it's a beam feature that I import once at the moment toolbars. I don't have the time to walk through the whole process here today. What I would say is there is a past webinar done on this topic. There's even a video dedicated to it. So if you do a search for Onshape beams, you'll find a past webinar that discusses importing beam profiles. I believe it's on YouTube. If you just do a search for it, you should find it. But it goes into a lot more detail on beams in particular, and it goes through importing in your own profiles. And there's actually a feature for that. So, all right. So the port feature is another example where you can see there's a rather complex hole that if I had to sketch it each time by hand, it would take quite a bit of time. I would have to sketch out a revolve profile, hope that I got all the various values right, and then, create them one at a time. And if I do a lot of hydraulic or pneumatic type work where that's a common operation, it becomes tedious and potentially error prone, right? So another example where FeatureScript can really make me a lot faster, right? a lot quicker when it comes to design changes. So we've discussed, how to use custom features. One last thing that I want to mention is if you're interested in other features, or if you're interested in the source code, seeing some of the source code of these features and taking them and building your own variation of them, what I'd recommend you check out is onshape.com/FeatureScript. So if you go to onshape.com/FeatureScript, there's a few very valuable things getting started. Right. So even if you're just interested in how to add custom features and what other features other people have written, this is still a page to check out. The reason I say that is you've kind of got your intro into what FeatureScript is, but more importantly, you've got all these custom features that are publicly available to you. So there's a fit spline, there's a beams feature, there's a port feature, there's point patterns, lap joints, gears, wiring. If you click more here, you'll see a lot more features are there. Right? So we don't have screenshots and a lot of detail for all of them, but definitely check them out if you're interested in custom features and adding custom features to your toolbar. So all of these are publicly available. You can add them to your toolbar right now. Now, if you're interested in creating custom features, there's a short video on getting started. I'm going to walk you through creating a simple feature in just a moment. But the thing I always like to mention, I mentioned this briefly earlier, Onshape has released the source code for its library of features, the part modeling features. If you click this button at the very bottom of this page, you'll be taken to the Onshape part modeling source code. So I mentioned this before. If you need to take the source code for whatever feature that you want to create, feel free to do so. Right? There's a document you can look up. This is the source code, by the way, for Onshape's Boolean command. Right? If we jump into, let's go to the chamfer command, for instance. Here's the chamfer command source code. So you can kind of get an idea of what things do in FeatureScript a lot by just looking at the source code from our standard library features, right? Now, another big reference that I would stress, another very valuable thing, more important if you want to create your own feature, is in the top right corner, under the help menu, you have this option for FeatureScript documentation. This is kind of, if you're getting started writing FeatureScript and you want to learn, what does everything do? How do I get started? What are some good tutorials? Those kinds of things. They can all be found under this help menu option, right? So under help menu, FeatureScript documentation, a few valuable things I would point out. First off, tutorials, right? There's a standard tutorial here that is step-by-step that you can walk through. And there's also standard library documentation. So if you're looking for a human explanation of what some of these things are, click on this standard library documentation and just do a search for whatever that thing is, right? And you'll get an explanation as to what that is, right? So here's a simple explanation of what op Boolean does and what all the various definitions are. So if you're looking for something specific, this is a useful, valuable resource. The last thing I'm going to mention here, there's a lot here, so I'm not going to spend a ton of time on it, but if you want to learn FeatureScript and how to write your own, the standard library source code is here as well. This just takes you to Onshape's source code, right? So for the Part Studio. Questions? Is there any plans to implement database connectivity with FeatureScript, or is it creating an application to link with Onshape a better option? I would say in that situation, creating an application is better. We do have an API today that will allow you to run certain things in FeatureScript. So I suspect what you're trying to accomplish may be possible today, but it's going to involve the API plus FeatureScript, most likely, because communicating into and out of a database would require the API. Remember, you can send values to variables, you can run different feature scripts all programmatically via the API, but you still need the API to exchange data between systems and trigger those scripts, so to speak. Is there any sheet metal or any feature scripts for sheet metal forming? There is the embossed foot feature. That's the only one that I can think of. And I think that is publicly available too, by the way. Embossed foot. If you do a search for it, you should find it. Off the top of my head, that's the only one that I know of for sheet metal forming. And it does, by the way, require you to have finished the sheet metal part, right? No different than if you were to model the form. At a company control level, can the admin control the custom feature scripts that all the users see? No. Now, I can share a document with my company's custom features and tell them use only these features, but there's no way to tell them you can't do anything else. You can't use a public feature. There's no way to restrict that as of today. What I have seen done is in that company environment, I create a document of custom features. I share that with the team. I tell them, here's where you pull in all your custom features and use these for your design. Unfortunately, we can't tell them you're not allowed to do anything else, but that is a solution. Are there any public parts, documents, or libraries that could be used for stamping out profiles in sheet metal? Onshape is growing. Clear how to browse to what other people have in the public domain. Is there any public parts or documents or libraries that could be used for stamping out profiles? I don't know that there's any public parts specific to stamping out profiles, but to be honest, I don't know that I've looked either. What I would suggest, and you can do this when you have a bit of time, is the public filter on the left, and then I like to search by likes. Now, there's tens of thousands, hundreds of thousands, potentially, I honestly don't know, of publicly available models. So there's just tons and tons of stuff there. But filtering by likes will give you a good idea of what's good and what's not so good. It's not perfect. You can also do searches by, searches only in the public documents for things like that. I'm not personally aware of any specific parts or documents used for stamping sheet metal. Right? Embossed foot is the only example I can think of that's sheet metal specific that would be public in that case. All right, so let's move on. Now, what I want to get into, bear with me for a second here, is creating a custom feature. So we've talked about how to add custom features, how to use some of these custom features. One thing I did note earlier is remember that any custom feature that's created, any feature that you use, or any feature that you create are going to look just like Onshape's features, right? The dialogues, everything's going to look identical. So you don't have to worry about a weird looking UI if you're creating a feature. It's going to look identical to Onshape's. The other thing I would stress is, remember, use that source code when it's available. There's a lot of publicly available source code, both in the form of Onshape's features and all of the features that I've shown you here today. Spur gear, port feature, straight spline feature. All of those are open source, right? So if you have a similar shape, you can copy and paste that code and edit some values around and potentially build your own feature without a lot of effort, right? They're all kind of, cookie cutter examples of things you might want to do with FeatureScript. So again, take advantage of that extrude source code, the revolve source code. All those things can be used to make the writing of your feature very, very simple and not something you have to literally type letter for letter. All right, so let's get into building a feature. Now, we've talked about using them. We've talked about how to find them. We've talked about using them as examples. But if I were starting from scratch, what would I do? Let's talk about building a custom feature, solving a problem with FeatureScript. One real quick question. Can you take a feature that was a model and add it as a custom feature? No. Well, I shouldn't say no. What you can do is I could create a document, put a part in, and then derive that into other things with FeatureScript, which I think is what you're trying to accomplish. Can you take a feature that was a model? Oh, feature that was in a model. I'm sorry. Can you take a feature that was in a model and add it as a custom feature? No. No, there's no way today to click on a model and say, make this a custom, or click on a feature and say, make this a custom feature. There's no way today to do that. Question. Are there any released Onshape features that the source code for which is not yet published? Not that I'm aware of. Now, when I say features, remember we're talking about part modeling features. So there's no assembly source code or drawing source code, of course. But part modeling, no, not that I'm aware of. I'm not aware of any features that are not openly available. All right, so let's get into creating a custom feature. Let's talk about solving a problem. So here I have this pump housing, and I need to add a lot of fillets to this pump housing, right? So I click fillet. I need to add a fillet. Let's say 0.03 fillet, and I come in here and I start clicking edges, right? And I just start going through and clicking all these edges. But you can see if I wanted to fillet all of these faces and all of these edges, I'm going to be here forever clicking on edges for my fillet. And if this is a common thing that I do, I don't want to do this over and over and over and over again, especially if I do a lot of casting design or something like that, where adding a lot of these small fillets in these corners is a tedious task for you. So let's look at how FeatureScript can solve this problem. I want to write a custom feature that allows me to click on a face and then grab everything that's connected and concave, right? So if we look at this, that's above it, concave relative to it, and connected to it. I want to grab all these edges, all by selecting a single face, right? So let's create this in FeatureScript. Now, the key thing to keep in mind with FeatureScript is you do all of your code writing in what's called a Feature Studio. So step 1, create a Feature Studio. I go to the plus icon in the bottom left corner. I click Create Feature Studio. That's going to give me a new tab in my document where I can write my code. So there's no IDE to download or install or anything like that. All the code writing is done right here in a tab in the document. Now, there are a few things to keep in mind. First off, the snippets make it very, very easy to kind of create canned pieces of code. So use the snippets. It just makes it very, very simple. So I want to start a new feature. There's a big button in the top left corner, New Feature Snippet. If I click that, it inserts the code snippet for a new feature. So that's kind of the framework, so to speak, for a new feature. Now I can start building my feature. I want to call this the pocket fillet, right? And I want to define my feature. Now, there's two important pieces to any program: the user interface and the actual actionable code, what runs. And both of them are held together in this FeatureScript code. So essentially you have the top half of your feature and you have the bottom half of your feature. The top half is where you define the user interface. The bottom half is where you define what actually happens when you run your feature, right? So let's start with the user interface. Remember, the goal of my custom feature was to allow the user to click a face and then grab all the concave connected faces that are attached to whatever that user clicks on. Then I want them to be able to input a radius value for our fillet, because we're going to fillet all those edges in one shot. So let's do this. Now, remember, snippets are useful. Snippets are going to be almost entirely what I construct this of. So I'm going to go to the top here for our feature parameters in the dropdown, and you'll see all these different snippets: length parameter, angle parameter, query parameter. In this case, the user is going to query a face of the model, right? And that's what they're going to do. They're going to click on a face, and we're going to query that face. So I'm going to choose a query parameter, right? We'll call this parameter face, and I'm going to rename this to definition.face just because that's what I like to see. So now we've added the first piece of the user interface for creating our custom feature. That's the selection that will allow the user to click a face. Now what we need to do is allow the user to input a radius value, right? They need to be able to punch in the size of their fillet. So we're going to go back to that same dropdown of snippets, and this time we're going to choose a length parameter, right? This allows them to punch in a value for a length or a size. We're going to call this radius, and we're going to call it definition.radius. So we've completed our user interface. Very simple user interface. The user clicks a face. They then input a radius value. Notice the filter that I have in this selection. It's entity type face, max number of picks 1. So I can define all these special criteria. If I wanted the user to click a point, it would be entity type vertex, right? So it depends what you're trying to do. In this example, we want the user to click a face, so I'm filtering by that. I'm only allowing them to use face and only allowing them to select one. All right, so we've defined the user interface. Now, what is this actually going to do? What's going to happen when we run our feature? So I like to do things a particular way, and I like to define my variables first. This, of course, is very much subjective, so just realize, there are lots of different techniques for writing code. I am by no means the be-all, end-all of writing code, right? But I'm just going to create a few variables and assign them, right? So now anytime I use face, I'm referring to the face the user clicked on. And now anytime I use radius, I'm referring to the radius value the user punched in. So I've just defined those two variables. Now what I want to do, remember their goal here is to grab all those concave connected faces. So I'm going to create a new variable called faces, plural, and this is going to be all those faces that are concave and connected to whatever our user clicks on. So there's a specific function for this. So I can go Q concave connected faces. Right? See it right here. Q concave connected faces. Notice that I didn't even have to type out the entire thing. I could just type Q and then scroll through all the list of different queries that we have. In this case, I want Q concave connected faces, and I want you to grab whatever face the user clicks on, right? So our variable here, face. So now we've grabbed all the faces that are concave and connected to whatever the user clicks on. Now we just say op fillet. Right? So again, I'm not going to type out the whole thing. I just left click here and it inputs all the various parameters that I need to create a fillet. Now, what are the entities that I want to fillet? Well, I want to fillet faces. Right? And what's the radius size that I want to apply? Well, I want to apply whatever the user punches in, which I have assigned to radius. So all we're doing here is we're saying grab all the concave connected faces and do a fillet based on whatever the value the user punches in. So that's really it. We've created our own custom feature. And in just a few minutes here, of course, albeit a very simple one, but it gives you an idea of what it takes. And the big thing I want to do here is kind of stress that if you haven't written any code in FeatureScript, if you're vaguely familiar with creating custom features, it's not all that difficult. And it's definitely something that you should give a shot. Right now, how do we use this? I've created this custom feature. Now I want to try it out. Right? So I want to commit. Very important last step before I can use it. Right? So make sure to commit, and then you can go over to your part and try it out. Real quickly, a few questions. Fillet 1. Oh, this, I believe, is what you're referring to here. So it says ID plus fillet 1. Keep in mind, anytime you create a fillet, chamfer, any kind of feature, really, it has an internal ID. And this is how you're defining that. And the reason this becomes important, is, especially when you start doing things like patterning geometry, because you need to increment the ID so that you don't have duplicates. But again, just think of it as, any feature that you create has an internal ID. And that's just the way really any parametric CAD system works. And in certain situations, if you're doing lots of patterns or things like that, you need to make sure to increment the ID, with common techniques for incrementing. But this is essentially just the fillet's internal ID. Question, forgive me. I have trouble seeing the whole thing here. If one opens a model where the feature that was added to a model by another user using custom feature, can you modify that feature if you don't have the custom feature set up on your toolbar? Yes. You can modify it. You won't be able to create a new feature. So yes, you will be able to modify, but not create a new. All right, so we've created our feature. Now we need to test it out. So you could go to a very simple part and say, now I want to try out my new feature, and it's just a matter of going to the far right of your toolbar. Once you've added a new custom feature, you're going to see this icon on the far right of your toolbar. If you hit the drop down, you should see your custom feature's name, right? So I choose Pocket Fillet, and here's my custom feature. So this is what we've created in the last few minutes. Now, remember, we had two things we wanted the user to do. Click a face and input a radius value. You can see that both selections are there. So we can input a radius value, let's say 0.03, and we can click a face. And what should happen here is you should go through and grab all the concave connected faces in a single shot, right? So you can see I've now added a 30 thousandths fillet to all of these edges with a single feature, right? Basically, anything that's connected and concave to whatever I selected. And if you do, any kind of cast design and things like that, these operations may be common, and it's something that could potentially save me tons of time, right? If you've ever been in this scenario of manually selecting or left-clicking individual edges to create your fillets, you'll know how tedious it can get when you have dozens of edges, right? So it's just a very simple example, but the main thing I want to do is kind of, dispel the myth that it's a complicated process. It's very difficult to get started. It's very easy to create a feature studio. Anyone can do it. And then you can copy and paste code from Onshape source code. You can copy and paste code from the publicly available features. You can write your own, inserting snippets like I've done in this example. So it's a very user-friendly environment, especially for those that maybe have just a bit of programming experience. CAD users who know a little bit of programming, but aren't necessarily experts. Chances are you could create something that's useful to you in FeatureScript. So that's what I had planned for you. I am going to stick around and answer any questions that you have. So I see there are a few questions that I haven't gotten to here yet. So bear with me. I am going to stick around and get to those. But that's what I have planned, everyone. I want to say thank you and have a good day.